All right, so today I'm going to teach you guys how to actually balance the equations yourself using something called coefficients. So let's say I give you an equation that looks like this. Please write it down. Magnesium plus oxygen gas becomes magnesium oxide. From what we learned yesterday, we know that this isn't balanced because there's a different number of oxygens on the reactant side from the product side. Today we're going to use coefficients to multiply the elements or compounds to get them to match on both sides. We are not allowed to add subscripts just because we feel like it. That'll be in a different lecture. Today we're just focusing on adding coefficients. So I'll do the first one and then we'll do the second one together as a class. The way this works is if I have 2 oxygens on the reactant side, I want 2 oxygens on this side. The thing that I can multiply this 1 oxygen by to get it to 2 is the number 2. Meaning we have 2 oxygen and we also have 2 magnesium. We'll get to the 2 magnesium later. The oxygens are now in balance on both sides. There's 2 on the product side and 2 on the reactant side. However, the magnesium on the reactant side is now at 1, while the magnesium on the other side of the equation is 2. The equation is still out of balance. So we now need to multiply the magnesium by something. Well, there's only 1 magnesium here. I drew the 1 there because if there's no number there, it's assumed to be one of them. And if we multiply this by 2, we now have 2 magnesiums present. And now the equation is balanced. Will it always be this easy? Not a chance. So we'll do one more together. And this time I will ask for some suggestions from you guys. I'm going to give you one of the more famous equations out there and see how to do it. All right, we're going to take hydrogen gas plus oxygen gas and turn it into water. By the way, note that at no time am I writing an equal sign anywhere. I'm not recopying the equation or anything else. So, here we go. First things first. I'm going to put lines in front of each one of these because that's where I can draw or write the coefficient. And I'll ask you guys, is this balanced, yes or no? No. The number of oxygens on both sides does not match. So what we're going to do is we'll stick a 2 here. Now we have 2 oxygens, but can someone raise their hand and tell me how many hydrogens are we stuck with at this point? Yes, Omar. We now have 4 hydrogens. While on the other side, we have 2 hydrogens. How are we going to fix this? Someone raise their hand. Yes?
Do you need to put a 2 before the 8?
We do. By putting a 2 here, we'll have that as well. And now it's balanced. As a matter of fact, this wasn't all that much more difficult, was it, than the other one? That was actually very simple. So let's do one last one, and then I'm going to send you on your way. Let's get one that for sure is going to change things. How about we do something with, let's do this. Aluminum oxide goes to aluminum plus oxygen. This will be our final example. All right, everything is off here, correct? How do we solve this? It is my advice to you guys to always start with the biggest number. So for the easiest lottery ticket ever, can somebody tell me what's the biggest number you see out there? Daniel? 3, congrats. There's 3 oxygens on the reactant side. There's 2 on the product side. Since we can only use multiplication right now, what is the lowest common multiple that 3 and 2 meet at? When do they multiply to meet for the first time? Oh, you put your hand back down. Angel? 6. So what do I multiply oxygen by to get to 6? And what do I multiply this one over here to get to 6? 2. And now the oxygens balance. Do the aluminums balance? Not a chance. 2 times 2 is 4. So what do I need to put there to multiply that one aluminum to 4? And that is the answer. All right?